Welcome back to Stewart Science. We're starting a new unit today, and that unit is all about changing velocity. So in our previous unit, you can go back and watch all those videos, we talked about how we represent motion 4 different ways. How we can draw it with a diagram, and that's what we're talking about today. We can talk about it with words. We can make a graph for it, and then we can find an equation for that graph and kind of represent it using math. So we have those 4 representations, and today we're looking at how do we draw an object? How do we make a diagram for an object that's changing its speed? And so what we talked about in the other video, just to quickly summarize, is that we need 3 things. We need to mark the 0 or the reference point on our diagram. We need to use dots to show where the car is each second. And then we need to use arrows to show which direction the car is traveling and how long those arrows are. Also communicates velocity. So here we have a car, and I'm going to show us how it moves. So after 1 second, it's going to be here, then 2 seconds, 3 seconds, 4 seconds. So you can see every second the car moved away from that reference point that we have marked. And so if I wanted to represent our object as a dot, those dots would look something like this. So you can see, just taking an observation, if the time between our dots is the same, let's say we make a dot every second, you'll notice that the dots get further apart. And that's because each second the car moves a greater distance than it did in the second before that. So as our time stays the same, our distance the car moved got bigger, which means the car is gaining speed. And if you'll notice, when I fill these in with arrows, those arrows get longer as the car moves away from its starting point. So the same thing is true in this kind of diagram that was true at a constant speed, except in the other example, our arrows were all the same length because the car's velocity was the same. In this example, the arrows get longer or shorter depending on if the car is getting faster or getting slower. So if I was going to describe this specific case in words, I would say, starting at the reference point, the car moves away, speeding up. It's going further from the 0 where it started, and the arrows are getting longer. The dots are getting further apart. So away, speeding up is this example. Here's another example. I've taken the car. I'm just going to show the dots. So starting at 0, you can see the dots get closer together as time stays the same. So tick, 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 tick. Over time, the car travels less distance than the second before it, which means the car is slowing down. So if I throw my arrows on there, you can see my first arrow is the longest, then it gets shorter and shorter and shorter until there isn't an arrow, because in the last dot, the car is stopped. 2 more examples. So this is slowing down away from 0. 2 more examples. In this example, you can see the arrows get longer and the dots get closer to the reference point. So this is toward the observer, gaining speed. I have a friend from high school who got run over by a car when we were in high school, and he's fine now, so I can joke about it. But I would say this is the example of my friend getting run over by a car. The car was gaining speed and then smacked into him, because at this point right here, the car reaches the observer. So at that point, this object runs into the observer. 1 more example. You can see here the arrows get shorter and shorter and shorter as the car moves, and the car's dots get closer and closer and closer and closer to the 0, or the reference point in this case. So if I was going to put this example into words, it would be going toward the observer, slowing down. And that's it. There's only 4 examples I can give you. Speeding up away, speeding up toward, slowing down away, or slowing down toward. There's only 4 options. Now, I could make it a little bit trickier by combining 2. So I'll give you 2 little bonus examples here. What if, let's say I'm throwing a ball up in the air, the ball is getting further away from me while it slows down, and then eventually it'll stop and then gain speed as it falls back down to earth. It would be that graph right there. As I let go of the ball, its distance away from me is increasing, but its speed is decreasing. So for the first half of the graph, you can see the arrows get shorter as the ball gets higher. And then eventually it comes to a farthest point, which is right here, where it stops, and then gains speed as it falls back down and gets closer to my hand, again, which is those last 3 dots. The opposite of this can be true as well, where something can slow down while it's moving closer to the observer, and then speed up as it goes away from the observer. And that's the example that we have right here. Our first arrow is long because it's fast at the beginning, and then it goes closer to the observer, but it slows down while it does. And then it gains speed again as it goes away. So 2 options there. Those are just 2 combined versions of the first 4 we talked about. So to wrap it all up, here we go. Here's what we should take away from all of this. Just like we did before, we need to mark the reference point, represent our object's location with dots. So we say where the car is over time with dots. That's the second thing. And then fill in the space between those dots with arrows. And those arrows show the speed and direction, which is what we call the velocity of the car. Before, when we had a constant speed, all the arrows were the same length, all the dots had equal spacing because the car traveled the same distance in that same time. Now our arrows are going to be getting longer if it's speeding up or shorter if it's slowing down. The direction is still indicated by the arrows. If the arrows are going away, like they are right here, that's in the positive direction. If they're going toward, like they are right here, those arrows are in the negative direction. So, just like we did before, 3 things. 0, dots that show position, arrows that show speed. Those arrows for these examples that with the changing speed should obviously get longer or obviously get shorter if the car is getting faster or slower. As always, this is Mr. Stewart. Keep learning no matter what.